Now we're going to imagine that someone has distributed charge on this plane, but subject to the following rule. That the number of coulombs per metre squared, the charge density, is given by some constant times x times y. So that varies across the plane, and I have to, therefore, divide the plane up into lots of small squares, and the assumption is that on each of those small squares, this is varying essentially not at all, and so I can then just multiply sigma by the area, whilst I can't do that for the whole plane. So delta Q of one of those little squares is given by the area times the charge density at that value of x and y. Now what I want to do is sum that up over the whole plane. So the total charge is going to be given by the sums in both the x and the y direction of k x times y dx dy. Again, it doesn't matter which order I do these integrals in, so let me choose to do the dx integration first. Again, what I'm doing is at some fixed y, I'm going to add up all of the little squares from left to right. Because I'm at fixed y, I can just bring anything relating to y, or indeed the constant k, out the front. None of that stuff is going to change as I move in this x direction, and I do the sum from 0 to L of x dx, and that goes to x squared upon 2, and putting in the limits, I get L squared upon 2. Now I can again sum those strips going upwards by doing the y integration. The k comes along for the ride. I again get L squared over 2 from the y integration, and there's the L squared over 2 from the x integration, giving me the answer of k L to the 4 upon 4, which is the total charge